Okay, hello students. Here in this video, this is again back to lesson number 2.1. Last time I completed exercise, and I think I completed from 1 to 10, and now I'll continue from 11. I think it goes all the way till 20, I believe. I don't know. We'll check it. So the first problem, that is problem number 11, is this one. In a Western music, the octave is divided into four pitches notes. For the film, Mr. the director Spielberg, he requested the composer to write a five-note theme. And when you talk about five-note theme, basically means on a keyboard, if you see that if this is the Y, there are like this, okay, and then there is a C, and then there is the black key here, if you remember. And there is a C, there is a D, and there is a E here, one more. And then there is F and G. Okay. So like this, there are, uh, what is the meaning of five note theme? Basically means D, E, F, G, like this. Okay. So you pick any of these H, you have G and then back to A and then back to B. So in between there are two black here and there are three black here. There are five black. So that's like a one whole 12 pitch. So basically it is C, D, E, F, G, A, and B, but in between you have C sharp, that's called black color, C sharp they call it, one semitone up, and then there is D sharp here, D sharp, okay, and then there is also uh, E sharp here, and there is F sharp and G sharp. So these are the five. So these are 1, 2, 3, 4, 5, 6, 7. So 7 plus 5 is like 12. So 12 pitch. So out of this 12 keys, you have to pick. So the John William, he has to pick any of those five out of these 12 pitches. So and create a music so that it sounds nice and cool. So the movie in this one is used that the close encounters. If you listen to the song of the movie, you will see that. My goal is only just to see, let's say, out of these 12 pitches, and this is called one octave. This from this C to another C is called one octave. And we disregard the rhythm changes. How many five note themes are possible if no pitch is repeated? So this is very important information. No pitch repeated. We can do this in two ways. The first one strategy we can use is fundamental principle of counting. So that means the first can be picked up in any of this. So there are 12 pieces. See, there are 12 here. You can see this is, I already showed the picture. So the first one, that means like this. So we need to pick five in order like this. So the first one could be picked up from any of this 12. So this will be 12 here. Once that is selected, you cannot repeat. So there's no repetition, right? So one of them is gone. Let's say you select the E. So the E is selected, and that means out of 12, uh, one of them is already gone here. This one is already gone. So there are 11 remaining. So from 12, 11 are remaining. So the second one, this one could be any of the 11 remaining notes. So I put here 11 here. So maybe this one is D sharp is selected. So I'll cut off this D sharp and put D sharp here. And the next one will be like, and so on. You can do 10 multiplied by 10. Sorry, this will be 9. And then there is 8. So the fundamental principle counting says just multiply 12, 11, 10, 9, 8, and you end up getting 95, 95,000 40. That's it. But we can use the other permutation formula because no pitch is repeated means the order is important. And when the order is important, we can use permutation. So what is the formula for permutation? So this n basically means the n part. So the n is 12, and you are picking 5 notes from 12. So that's the R. So the formula is uh, NPR is n factorial divided by n minus r factorial. So all you do is plug in 12 factorial divided by 12 minus 5, and which is same as I can write this as 12 and then go all the way, reduce it by 1, all the way to 8 factorial. So to 8 and then also go until 7 factorial because the bottom one, see this is 7 factorial. So we can cross out the 7 factorial there. So this piece crosses out and you get the answer. 12. Same thing. See, you get the same thing here. 11, 10, 9, and 8. But the question is, do we have to do this? No. You could directly also use the formula and write down this as 12 P5. And let's use the calculator. Let me go back to the calculator. You see this calculator and start with click on the function here. Then go to NPR, plug in 12, then comma, and then put 5, and you get the answer 95,000. So this is how it works. Okay, I hope uh, uh, I made sense. So let's go to the another problem, which is question number 12. Question number 12. So, in the 20th century, proponents of the second Viennese School of Music composition, including this guy, 3 of them, they devised the 12-tone technique, which utilize a tone row consisting of all 12 pitches of the chromatic scale in any order. In any order, see, the order does not matter here. Then, but with no pitches repeated. Oh, but with no pitches repeated. So that means order matters. Disregarding the rhythm and the octave change, how many tones are possible? So that means there are, as I said, C, then C sharp, then D sharp, then there is E sharp like this. So it's better to see the visuals of a piano here. This is the piano. And what is the meaning of an octave? Basically means this is what start the C and until here. This is one octave. Now this one has got one white one, that is C, D, this is E, this is F, this is G, this is back to A, and this is B. Okay, start with C like that. This is D, this is E, uh, this is F, G, and this one is A. So these are all together 7, and you see that the black color ones that you see, those are, so this is called C sharp, this is called D sharp, this is called F sharp, this is called uh, G sharp, and this one is A sharp. So these are 12 tones, see? 12 tones. Now, so that they are asking you from these 12 tones, if the order matters, how many different different ways can you uh, divide this like this? See? Uh, uh, So the first one could be selected. Like, so let's see if I want to. So these are the 12 places or the order. And the first one could be any of these pieces. It is C, D, E, F, G, any of these 7 plus 5. These are 12 altogether. So there are 12 of them. So we can pick any of those 12. Once that is done, the next one could be selected from the. So once this is filled up, and let's see if I fill this with the D. So this D goes right here. So 12. So that means the remaining will be 11. So we need to fill the 11 tones from this 1, 2, 3, 4, 5, and this 6, 7, 8, 9, 10, and 11. So that means the next one we can select from the 11. So that's why we say 11 here. This will be, then remaining will be 10, then remaining will be 9, and so on. See, and you can see the pattern there, 6 and 5 and 4, then 3, then 2, and then the last one remaining is 1. So all you do is the answer is you multiply. So you go on multiplying this. It means it is 12 times 11 times 10 times 9. Okay. So basically what you get uh, is is nothing but 12 factorial. Okay. So this 12 factorial means by definition, or there is another way to say is also two different ways. You are making permutation from 12 and you are taking all 12 at a time. So not just few, but so the last example we were taking 5, but you are picking here all 12. So either you put this or this, and we'll put this in the calculator and see what do we get is see this in the calculator. Let's take off this and go to the click on the function NPR, and you can put 12, then comma, and again 12, and you can see the answer is 479,000. This is the answer, 479,000, 1,600. But we can also use another different ways and directly write 12, and put a factorial. So go to function and there is a factorial right here, and it's the same answer. So what did you learn here is also that that we have n, where is that? What did we learn is 12 n p n is same as n factorial. So it's like if there are 5 friends, let's say if there are 5 friends and they want to take a picture and they want to stand in a row like this and they want to take a picture standing, how many different ways can you take, how many total number of pictures can be taken? And that's what that means. It means from 5, all 5 are moving around. That's why it is 5p5. It will be like 5 factorial, something like that. And I hope, so the answer for that, what we got here is 479 million, then 1,000, and then 600. And you saw on the calculator, we got the same answer. Okay, so that's it. So this was question number 12. So question number 12 is slightly different. It doesn't, in how many ways can 4 pizza topping be chosen from 12 toppings? So let's say you want to make a pizza and they need to put toppings here and they have available there are so a lot of, see these are all the toppings that could be put pick and put on top of the pizza base. These are all together 12 like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 and 12. So from this you need to pick 4 pizza toppings. It could have been this, or this 4, or it could be some other topping. Could be this, and this. So how many ways can you do? It does not tell you the order. The order in this exam order does not matter which one you're putting. just picking any of the five can be picked from, like the red one. These are the red ones I picked. Uh, I think I forgot to put another one. Maybe this is the red one, five. So these are the five. No, no, they want only four, right? So that's not the one. So only four. So that means from this is combination. So combination basically when you pick four toppings, it does not matter which one you are picking up. So the whole thing gets reduced to so the whole thing gets reduced to is from 12, we'll have to use 12, C, and 4 because 12 is the available toppings. That's the N because when you talk about NCR, it is N factorial divided by R factorial and then N minus R factorial, right? So we can use this and write down, okay, 12 factorial, then this 4 factorial, that's R, then parenthesis, you subtract the 2 and write the factorial again. So working this way we get, and this will be, this 12 minus 5 will be 8. So I'm going to reduce this until 8 factorial. See? Okay. And then this is divided, and this 4 factorial I can write as 432, and the other one I'm going to write just a 8 factorial. So we can cross out the 8 factorial. This crosses out. So what I remaining is just use the calculator, does the job. So you multiply this for the numerator and get the answer, and multiply this the denominator. So if you see, if you really work this out, you get 11,880 and divide by 24, and you get 49. Let's check it directly. So what I'm going to do is, this is the right way to do it. Since we have a technology, we can put this 12 straight away, 12 C4. We'll put in the calculator. So this is this calculator right here. Okay, and I'll start with a new one. Go to the function, and there is the right here. There is this, click here, and then since we have 12 toppings, so I'll type in, go to the main, and then 12, and then comma, and you need to pick four of them. And you see that 495 answer. So there you go, you get 495. So I go back to the problem and say you got 495. So those are different combination. You can pick four pizza toppings from 12 pizza toppings. So that's the answer. Let's go to question number 15. Sorry, 14. Hmm. So this is a question about baby shower. There are 17 guests are in attendance, and five of them are randomly selected to receive a door prize. If all five prizes are identical, in how many ways can the prizes be? So that means these are, let's see, there are 17. So you see there are 17, that is n is 17, and there are five prizes to be given. So see, so let's see, this is for one. So these are the five boxes gifts to be given, which we call door prizes. Now these door prizes, the first prize. See, so the first prize, let's see, one, two. These are the five door prizes, and since there are 17 of them, so the first door prize can go to any of this 79. So, or we can see from 17 members, these are 17. We have to give away all these five prizes. Now the order does not matter. It does not say uh, which one value more. They are all identical. The main word they use is identical. So just so if you have five prizes, you need to select five members from this, and you give these prizes away. So how many ways, how many total number of combinations are possible picking 5 members. So that means your this one is 5. See, these are 1, 2, 3, 4, 5. So you select 5 members guest. So that means the R is 5. So from 17, that means the formula is NCR. So there are 17 guests, and you are picking 5 of them to give the door prizes. So the formula is, even though I'm writing everything, it is because of the formula 17 factorial, then this, and then you subtract this, okay, and put a parenthesis and you get that. So, and you work on this. So this will be, I'm gonna go down this to all the way because the 17 minus 5 will be 12. So I'm gonna write 17, 16, 15, 14, 13, and 12 factorial. See? And then divide by this 5 factorial will be 5, 4, 3, 2, and 1. 1 is not needed. And this is 12. So that 12 factorial can be crossed out. And you do this maths for this numerator and denominator separately. And you can get, you will get 7, 4, 2, 5, 6, 0. Divide by 120, and then put on the calculator, you get 6188. So the question is, do you have to do all this work? No. You can put this directly on the calculator and we use the new one. Go to the function and click on NCR, and there are 17, comma, okay, and put 5 door prizes, and you get the same answer, 61. So there it is, 6188. That's what we got here also, 6188. See? So two different approach is here. One is showing all the work. You can see here, you show all the work, and one is you can just use the formula directly, put it in the calculator and get the answer. Now this is about lottery. You can see there are from, so you need to pick 6 numbers from, so if these are the lottery, let's say these are the lotteries, 50 of them all together, 50, and from this 50 you pick, so each one of them has a number. So the first one is 1, so this is 1, 2, 3, 4, 5, and so on, and it goes to 49 and 50. So you need to select any 6. So you need to correct 6 of this. And I don't know, we can do any combination. I could do this, some here, then some here, maybe 6, 7, and then I can pick this and this. So this would be one combination of 6 numbers, picking 2, 4, 5, not 5, 6, 7, 49, and 50. So these are the 6 numbers from. So this is one combination. And likewise, how many combinations, how many combinations are possible? So all it is, because there is 50. So picking these 6 numbers, remember, does not, the order here, the order does not matter. Order does not matter. So it is a combination problem. So we're going to use the formula for combination, that is NCR, and the N is the number of 50, and then the number of uh, lottery that you're going to pick is any of the 6. So it is 6. You just put this on the calculator. Of course, you can use the formula also and say, hey, the top one is this, then it is 6 factorial, and then you subtract. Okay, you could do this way also, and 50 minus 6 will be 40, 54 factorial. So I can go down this and write 50, 49, 48, 47, 40, so many numbers. So it becomes difficult to write this. And then 40, 50, sorry, 50, 50. 45, I know. This is 40s, 44, right? Yeah. This is 44 factorial. So we can cross out this 44 factorial. And I think I missed this 6 factorial, which is 6, 5, 4, 3, and 2. And multiply all this, okay? All this until 45. You end up getting into the directly the answer will be 15,890,000. Let's check whether it is really correct. So we'll put this directly in the calculator. 50C6. So go here, start a new one. Function C 50, comma, and you want to pick 6 of them and see, and that's how you got 15,890,700, and that's what we got right here. See, so I hope this makes sense. And a few more problems and we are done. Question number 16 is the easiest one. You had in a day lottery daily game, a player picks 3. That means the R is 3 here. From 0 to 9. The digits from 0 to 9 are, how many of them are there? They are all together. You can see they are all together 9, 10 of them. These are all together 10. So that's the end. Now, he wants to pick 3 numbers from here. So you can pick any, how many ways can you pick? So I could pick maybe 2 here. I could pick 5 here, or I could pick 8 here. So this will be one combination. See, the order does not matter. Just a group of 3 numbers are picked up. So how many ways can you do that? So the formula is the same. Tens. This is a combination problem. So NCR, which is 10C3, because we are using 3 of this. So this will be formula says 10 factorial, and that is the n factorial, then the 3 factorial, which is r, and you subtract the. So I want you to get this understanding how it works. This will give you 7. So the top number, you go on reducing. I think I missed 9, 8, and till 7 factorial. This 3 factorial is 3 times 2, and this is 7 factorial. You can see 7 factorial and 7 factorial cross out. You get 10, 9, 8 divided by 3 times 2. You can use also without calculator. 3 goes 3 times, and this 3 also goes 2 times, and this 2 goes 4 times. You get 40. But if you get confused with this, use the calculator directly. 10p3. So sorry, 10c3 from the calculator. Okay. So click on the function, then click this, and you have 10, then comma, and put a 3 and see. Did I miss a number? I think there. Let's check. 10p3. Where did I miss? Go back here. 10, 9, 8, and divide by 3 times 2. 3. And I think I missed the 2 here. There was one more 2 which I missed here. 3 times. Let me do this one more time so that we really understand what's happening. So this is 10 times 9 times 8, and the bottom is this 3 and 2. So 3 times 2. So 2 goes 4 times, 3 goes 3 times. Okay, so you get 10 times 3 times 4, and 3 times 4 is 12. 10 times 12, and you get 120. So that's the answer we did get in the calculator here, 120. Okay. So as we are working on this problem one, so many of them, you get a hang of working with combination and permutation. So let's do the next one is jury problem. So there are 27 members here. Okay. Uh, so question was a jury pool consists of 27 members. Let's say this is a big group of 27 member jury pool. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 27 left. And you need to pick 11 people to be chosen to serve. So there are two parts here. One is this, and once you do 11 of them, and one additional person is chosen to serve as the jury foreman. And the foreman basically means the leader. It means not just you select 11 people. So from 20, so I have to pick 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are the 11 members I have. So let's this is the A, B, C, D, E, F, G, H, I, J, and K. So these are 11. So how many ways can you pick this 11? And you see, the order does not matter here again. This is a combination. Who is selected first doesn't matter. First step is you pick any of the 11. So you're going to use NCR, which is, in this case, there are 27. So that's 27. And then you are selecting 11. So that means there are from 27. You're going to select 11. And we'll see what is this answer for. And because once that is done, then we have to also, there's another task is from this 11 member, these are 11, you need to select one leader. So from here, who could be the leader? Sorry. So these are the first one. So these 11 members are first selected, but the leader is to be selected not from this. I think I read it wrong here. It's from the additional person to be chosen to serve as the jury foreman. It means once you are done with selecting this 11, okay, so once you are done with selecting 11, so that means from here, I'll take off 11 of them. How many are remaining? Let's see this. So, row from 27, you take away 11 and you're left with 16 remaining, right? So from this remaining, you're going to pick a foreman. So if these are 16 remaining like this, these are 16, let's see, I don't know, I'm just counting. Then from here, you select one. And so the additional person to serve as a foreman could be any of the 16. It means he's going to pick 16 C1, which is same as if I'm picking only one, there are 16 options. You can see also the formula. So there are two parts. One part is this. The second part is 16 here. So, and then you just multiply by the fundamental principle of counting. So if you see, put this on the calculator, 20cc level, you get 13 million. So this is what you get. And then finally, how many different ways can this 11 people be chosen to serve jury and one additional? So your final answer is, let me wipe this. So the final answer is, so the final answer will be, and you can see also if you get confused, you can use the calculator Y. It's like always remember if we have a NC1, the answer is always N. Uh, so so we can use the fundamental principle of counting. That means it is so the total number of ways is the first task was you're picking 11 members, and that can be done in that is 27 C11, and then once that is done, you're picking the remaining from 16. You pick one, so that is 16 C1, and you can say this is 13,000, and you multiply by 16, and the calculator gives you 208,606,32, and you're done. So this is what you get. And you can check this whether it is really true. Let's go to the calculator and do that. So here is the calculator. Mm, So click the function NCR. So it is 27, comma 11 times. So you multiply again, go function, see, and it is 12. Sorry, how many are remaining is 16, right? So 16, comma 1, and you get the same answer. So this is like a shortcut to find out this way. But what I did here was to show steps how it works. So the first task is working this piece. This is the first task, selecting 11 from 27. And the second task is this one. From the remaining 16, you pick one. And then whatever the answer, which is this is 16, that 16 and these two pieces are multiplied. Here it is. You get the answer. If you have questions during the regular time in the class, you can question me. We can work this together also in the classroom. So this is the last question from our lesson 2.1. Now, a similar question was done earlier also, just in case we forgot. So United States Senate Committee of Commerce, Science, and Transportation consists of 23 members. Let's say this is 23 members where there are 12 Republicans. So let's put a color for them. So there are 12 Republicans, and then there are 11, there are red. Let's see, there are 11 Democrats. So these are Democrats, okay? So now we are from these 29, we need to pick, these are altogether 23 members. Here it is. From here, you need to make a committee of Surface Transportation and Merchant Marine Subcommittee, consisting of, that should be 8 and 7. That means 8 plus 7 is 15 members. So you need to have a 15-member subcommittee from this one. So, but at the same time, there is also restriction that the first these 8 members has to come from here. 1, 2, 3, 4, 5, 6, 7, 8. So that means the first part, how many ways can you select 8 from the 12 Republicans? So there are two parts here. The first part is NCR, because this is also combination, does not matter the order in selecting. What matters is you have N is 12 here, and your R is this. So you put 12 C8, and then we can directly use the formula because now that we know how to go about, so it is 495. Now I'm going to use the red color to show. And this one has to be 7 because that's what it says. 7 Democrats, right? So 1, 2, 3, 4, 5, 6, 7. So that means there's the second part, and the second part is again NCR, but this time there are 11 Democrats, and from this 11, you need to pick 7. Put that in the calculator, and you get 330. So your final answer conclusion is you have to just multiply using a fundamental principle of counting. All you do is or how many ways can members of the subcommittee be chosen from the committee. So you just multiply this 495. So basically it is 12 C8 times 11 C7. It means it becomes 495 times 330. And when you multiply this two on your calculator, you end up getting 1,163,350, and you're done. So this completes all the exercise. That means we did all the examples, and the last time video was very big. So this one is a short. This one does from 11 till 18. And I hope this will help to prepare ourselves for the exam too, because chapter 1 and chapter 2 together will be exam 1. So this is like a study guide also to help you. Thank you so much for watching. We'll continue in the class.